This is Geometry Lesson 10-8, Secant and Tangent Angles. All right, everything today has to do with angles, and everything in the next lesson has to do with side lengths, or just lengths in general. So today we're talking about a few different formulas. I have 3 unique formulas for 4 diagrams. Let's jump into the first one. So in this case, I have this angle and this angle. If you add that together, you get twice of this angle. Another way of writing that, I can divide both sides here by 2, and I can say divide by 2, divide by 2. That means I have C by itself, because 2's and 2's cross cancel, leaving behind the C, and that's equal to all of this, A plus B over 2. This is the one that I tend to remember, so if you had to star either this formula or this formula, I would prefer this one because it just comes in handy. It's another way of saying the average of A and B, because again, the way that you do an average is you add the 2 things together and then you divide it by 2. We're adding them, dividing by 2. This formula gets confusing because if you come down here, it's the opposite. You're going to subtract these 2. So again, let's go ahead and rewrite this formula. I guess before we rewrite the formula, notice what it's saying. It's saying if you do arc measure A minus arc measure B, there's A right here, and you subtract B over here, you get twice of this angle. Same thing over here, right? If I do larger arc minus the smaller arc, you get twice of this angle. This formula goes to both of these 2 different diagrams. So let's go ahead and rearrange this. We can divide both sides by 2. Divide by 2, divide by 2. And you get C by itself. Again, the 2's cross cancel. And now I get A minus B divided by 2. A minus B divided by 2, which is very, very similar to the last formula that we had. We had A plus B over 2, and now I have A minus B over 2. So just remember that when I have a big arc and a small arc, and then some sort of angle on the outside of the triangle, or outside of the angle, outside of the circle, what am I talking about? Outside of the circle, then it is a subtraction, and anything that's on the inside of the circle is going to be an addition. And then we have this other third new theorem, which is kind of cool because it looks very similar to an inscribed angle, right? An inscribed angle would be this angle that goes like this. You'd say, okay, to get from this angle out here to this arc measure, you just multiply by 2. Well, now I've turn this into I don't even know. This is not an inscribed angle anymore because I don't come back out to another circle. This is just a tangent line, but it's still saying, hey, you want to get from this angle out to this arc measure? Well, again, you just need to multiply by 2. So it's the old formula, right? So again, you can rewrite that formula into maybe another form. You can say, okay, well, I want to divide both sides by 2. Therefore, A is the same thing as 1/2 of B, or you could say it's a B over 2. Either one, I prefer this formula actually over the 2, but it is kind of an opinion-based question after that. So let's go ahead and try to apply these formulas. All right, number 1, I know that if I add together this angle and this angle, it will average to this angle. You can kind of tell, like, okay, well, what number do I have to add to 40 to average at 30? Well, it needs to be under 40, and it needs to be under 30. It's probably 20, and it is indeed, but let's do the math to show that. I can say that 40 plus my unknown angle, which I'm going to go ahead and call x, plus x, divided by 2 should be equal to 30. And then from here, I'm just going to solve. I can say, okay, multiply that side by 2, multiply that side by 2. Whoa, my pencil is not working. I think I have dropped it 1 too many times. And then that means that these 2's are going to cross cancel, leaving behind just this 40 plus x, and that's going to be 60 on this side. And then finally, we are going to subtract 40, subtract 40 to get x is equal to 20. Our intuition was correct. That's 20 degrees technically. All right, what about the next one? The next one is basically an inscribed angle, right? An inscribed angle means to get from this angle out here to this arc measure, we multiply by 2. So I can immediately multiply by 2 and say, okay, this angle over here is actually 80 for the arc measure. And then if I want to get to this arc measure over here, I happen to know that if I add together all of the measures of the outer part of the circle, they should add up to 360 degrees. So I can set that as a formula, right? I can say that if this angle or this arc measure is x, I can say arc measure x plus 80 degrees should add up to 360 degrees. And then from there, I can just subtract 80, subtract 80. And then I can come down here and say, okay, x is going to be equal to 280. Technically degrees. Excellent. And box it. All right, what about the last one? This one is tricky, right? Because I have 2 different things that I need to subtract, and then that should be equal to twice of this angle 40 degrees. The problem is I don't know 2 different things. So let me go ahead and write what I have. I can say, usually the thing I'm trying to solve for, I'm going to call x, and that means that this length over here, from here all the way around to here, I'm going to call that y, I guess, for another variable. I know that if I do y minus x, if I do the large arc minus the small arc, I should be equal to twice of 40. I can say, yeah, I'm just going to say twice of 40. No, okay, but I'm going to go divide by 2 and then make this 40. I'm going to use that fancy formula where it's kind of like an average but with a subtraction. So from here, I'm going to try to solve, but even if I try to solve, you'll notice I get stuck because I have 2 different variables with one equation. And this is one of those things I've told you guys over and over. If you have 2 different variables, you need at least 2 equations. So where does that other equation come in from that relates x and y? Well, check it out. X and y add up to a full circle, which means I can say my second equation is really x plus y. Adding them together gives you a full measure of a circle, which is 360 degrees. And now the fact that we have 2 different equations means we are ready to solve. I'm going to go ahead and multiply both sides by 2 here and say that this is times 2 times 2. And now these 2's have cross-canceled, gone and gone, and that leaves me with a y minus x, and that's equal to an 80. And this is the way that I prefer to solve this. I noticed that if I were to line this equation up and copy and paste it down here, in fact, I have technology, so let me go ahead and copy and paste this down here. Notice that if I line them up and I add them together, well, okay, these x's and y's are not in the right spots, so let me switch these. This is going to be a positive y and a positive x. There we go. Notice that the y's line up and they just add to 2y. But if I add the negative x and the positive x, they eliminate. And by adding these 2 equations together, I've actually solved the system of linear equations using elimination. So let's go ahead and do that. I'm going to go ahead and say, add these together. Well, y plus y is 2y. And x minus x is nothing. They cancel each other out, and I'm left with my equal to sign. And then I can add together 360 plus 80. And this is going to be 440. And then from here, I just need to divide by 2, and y is equal to 220. Now here's a problem. Where are we trying to solve for y? I mean, y is this length over here. We're trying to solve for this question mark, which is technically x, which means I need to resubstitute in y is equal to 220, either to this y right here or to this y right here. It doesn't really matter to me. I'm just going to do that one because there's more room over there. So I can come over here and say, okay, well, this is now x plus y, which is now 220, and that's going to be equal to 360. And then from there, I can just subtract. Why did I write 222? I don't know. Brain's not working. It's late. It's not my fault. All right, this is going to be 220, and then subtract 220, subtract 220, and then from there, what do we get? Ooh, Apple Pencil is having really big struggles right now. X is going to be equal to 140, and you can just do like a sanity check, right? 140, 220, those do add up to 360. Therefore, we have our answer of x. X is 140 degrees, technically, right there, and we have our answer. All right, that concludes the notes for topic 10-8, secant and tangent angles for geometry. Thank you for watching.